All right, we got a little bit of a late start there. The class ahead of us was getting out. Is everything on the Zoom coming in okay? You just hear me okay? Anyone want to confirm that for me as I start here?
Yeah, you're good.
Okay, perfect. So for today, hopefully everyone who's here, you're on the Monday list. So this should be the first time you're kind of in class. I was looking at the online quiz results about who wants to attend in person. We're just a couple people too many. They kind of just have two groups, so you could get in some weeks twice and the next week once and so on and so forth. But I have a couple emails out there. I know everyone's busy, but I'm trying to get us in a classroom downstairs. I think I mentioned that last week. So should be, look for an announcement on Canvas, but I'm thinking it's going to be 136 or 138 downstairs we're going to end up in. There's a couple more seats available, and I should be able to get a list where we basically, instead of having three groups, Monday, Wednesday, Friday, we end up with two, right? So you'll kind of meet every other class period. So I'll get that seating chart updated as soon as I know what room we're in and kind of how we'll have everyone seated. But look for that announcement on Canvas. Hopefully today, if I get the email. If not, I'll go badger someone in person tomorrow. So that's kind of where we're at with that. What should you have done before you got here today? Two things. Most of you did the first one. I just mentioned it.
Quiz and the
quiz.
Whatever.
And you're about to say the Learn Smart, right? I'm guessing. So hopefully you got on and got that done. Got the easy points. I'll get another Learn Smart up there today. That'll be due by the end of the week. So Friday. Once again, it's just more so to kind of keep you used to kind of being involved in the class. It should be a really easy 10, 15 minutes, just kind of walk through, get primed for the next topic we're going to talk about, which we should be able to start on Wednesday. I don't know how far we'll get into it, but we'll definitely be doing that Friday. So where did we leave off? Okay, so not on the class list. So we were dealing with, where was it? I came up with this kind of car color data set, right? We were dealing with qualitative variables, right? These are just words, descriptive words, not numerical yet. The other data set that we have been looking at was this, kind of cause of death, okay? So we'll kind of bounce back into Excel here in a second, but just kind of remember that we had that data set sitting there. So we had all these different causes of death. We talked about how we could go from frequencies to relative frequencies to percent frequencies. So how did we do that? That was as simple as, to get the relative frequency, we took this frequency and divided it by the total number of observations, right? That gave us the proportion of deaths that were coming from heart disease. To turn that into a percentage, all we did was multiply by 100, okay? So that's how we came up with these percent frequencies for each of these different types of deaths, which really, you think of the cause of death here as our qualitative variable we're trying to get a frequency distribution for, okay? So, a couple things we mentioned, those things, those percent frequencies should hopefully add up to 100% if we did it correctly. Now, let's say I wanted to go ahead and kind of graph this, right? So, well, here, you kind of already have it here, but I'll kind of walk through how we would do this, right? And don't have like a whole lot of board work to do today, so anytime that's the case, I'll probably just do it through this annotation thing on Zoom. But kind of moving forward, I'll be over here, I'll pull one of those desks up and we'll be doing a lot more board work. But just to kind of show you a couple things, if I don't need to use the board a lot, it's a little bit easier to kind of have it set up over here, right? So let's say we kind of have this graph and we're thinking about, we want to put this frequency distribution into like a bar graph, right? So what we're going to do, right, is say, all right, what's this very first category? I think we had the disease, or the cause of death was heart disease, right? So we've got heart disease. What we're then going to do is we're just going to draw a bar that goes up to however many deaths there were. So I think this one was like 5.5 million, right? That'll be our y-axis, is kind of our frequencies, right? We just plot the frequency for each cause of death. So first I do heart disease, then I do, I have another one over here. I think it was like malignant neoplasms, which is essentially cancer. I don't think that one was quite as high, right? So if we think about where that one was, if I'm trying to plot that in the y-axis, I think that was something like 4.4 million, right? So, the bars will go up higher when the frequencies are higher. right? Because that's just kind of how graphing something works, right? As the y value gets higher, that bar would be larger. Right? So we would go through and do this for every single cause of death. And then once we get to the last one, we have this nice bar chart that kind of gives us this frequency distribution for whatever variable we're looking at. So I did that here. Oops, here it is. Right, so we've got heart disease at 5.5 million, cancer 4.4, so on and so forth. And especially if you plot these after you order them, it kind of gives you this nice identification of, well, look, these bars are way higher, right? This is definitely where the most people are the highest cause of death, right? Where most people are dying. And then, yeah, there's some important things here, but right, they're not near kind of carrying the weight that these other two are. And so if I'm trying to argue for, money in terms of my whatever I'm studying, if I'm looking into heart disease, this probably convinces whoever has the money that, yeah, you should probably direct some towards me, right? Because this cause of death is much greater than anything else here. Okay? Now, we talked about if we had those percent frequencies, right, we could actually do the exact same thing. It's just instead of plotting the frequencies on the y-axis, for each cause of death, instead of using frequencies, we could just use these percent frequencies, right? So if we do that, right, it would look something like this, right? So a little over 30%, a little over 25% are coming from these two causes. Everything else is well under 10%, right? And, depending on what kind of you're trying to, who you're presenting to, what the situation is, maybe here I'm thinking about, if I can show that I'm a larger percent of overall deaths, maybe it's more likely I get some of the funding. In other situations, maybe like letting them know exactly what the number of people is might play a little bit more, maybe pull on their heartstrings or something like that, right? Just kind of depends who my audience is. But notice these graphs, if you didn't have the y-axis, look exactly the same, right? So why is that the case? Well, I'm dividing every single one of those frequencies to get my relative percent frequency. The first step was divided by the total number of observations. Well, if everything gets divided by the same number, the relative size doesn't change. I always say the best way to think about it, so 2 is half of 4, right? So if I divide 2 and 4 by 2, I now have 1 and 2. 1 is half of 2, right? If I'm just basically scaling things if I divide it by the same number. Same thing if I multiply something by the same number, right? So, 5 is half of 10. Multiply those both by 2, 10 is half of 20, okay? So if I'm multiplying and dividing everything by the same number, the relative size doesn't change. It's just a matter of what do I want to show on the y-axis, okay? And the procedure to graph that is going to be the same no matter if I use frequencies or percent frequencies, right? It's just the number that I plot on the y-axis will be different, okay? So if we go back, oh, and before I go there, we can do pie charts as well. I'm sure you've seen these in middle school science or something, probably had to do these. The larger the slice of the pie, right, represents a higher percent of the overall. Okay? So if we go to that kind of color data set we were working with, I had the frequency distribution right here. Right? There was 3 red cars, 4 blue, so on and so forth. If I just wanted to create a bar chart using these categories, right, instead of my causes of death, now I have car color, and using here, I guess we can think about these are my frequencies, right? If I highlight those labels, right, or those different kind of responses I could see for that variable, and then their frequencies, I go to insert, I go over here, there's all these chart options. Go to this one that says column or bar chart. We're gonna just do a column chart. You could do 3D, you get fancy with it. And then this kind of just shows, right, here's the 2 most common car colors. The rest aren't quite as common, whatever the situation is going to be different. But the higher the bar is going to tell you that's where the majority of the responses are for that variable, right? The majority of cars here are red and blue, okay? And it's as simple as highlighting those labels, those frequencies, and inserting that bar chart. Now, if I just selected the frequencies, and I try to insert that column chart, notice I don't have any labels down here. Well, that doesn't really, still get the same chart, but I have no idea what these different responses are. Now, the easiest way is to just select it ahead of time before inserting the chart. Let me see if I can show you. Here we go. So if you left click on these numbers down here, and then we right click, and then you go to select data, what you can do after the fact is say, okay, here's my horizontal labels. Right now they're just numbers because I forgot to select the names, right? So if I go to edit, and before I do that, I got to move my chart since it's covering up my data. Okay, so here we go. So we go to select data, edit that horizontal axis, select my labels. Now when I hit OK, notice those numbers have all become those labels. So even if you forget to do it, you can add it in after the fact, but it's a lot easier to do, just highlight it before you insert the graph, okay? So I think that's pretty easy. We could do pie charts as well. So let's see, let's select this. Let's go to insert. I think it's this one, right? We got a pie chart here. We can do this 2D pie chart, kind of showing the different responses just in a little bit different way. Okay? It's that easy, right? Once you highlight the data, Excel really makes it easy. Just insert whatever type of graph you want. Okay. All right. So we'll go back here. Okay. So last class, and just kind of a brief reminder, we were working with qualitative variables, right? So what if we have quantitative variables? Okay. So now instead of counting the number of responses for how many cars are blue, maybe I want to count something like, I asked, how many children are living in the household? So now I want to count the number of responses that were 0, the number of responses that were 1, the number of responses that were 2. I can't have half children in the house, right? So I've got this nice integer responses. I've got this discrete variable. Well, everything would be exactly the same, right? Now, instead of using that countif function in Excel to count the number of cars that are red, you would just count the number of responses that were equal to 0 or equal to 1, right? But the procedure is exactly the same. Then once you have the frequencies, how do you turn them into relative frequencies? Divide by the total number of observations. How do you turn them into percent frequencies? Multiply by 100. Nothing changes at all when we're dealing with discrete variables, right? We just treat every single integer response like it's a word, just like it was a word with a qualitative variable, right? Nothing changes there, right? So that's pretty easy. But what if I have continuous variables, right? Or continuous data? Well, let's think about income. So the very first thing I would have to count the number of responses that had $0 for their income. Then I have to count the number of responses that have 1 penny as their income. Then I have to count the number of responses that have 2 pennies for their income, right? That's going to be pretty much impossible. Right? I mean, not impossible, but by the time I get done, I'm going to have this graph that extends the length of this university, right, with the different possible salary amounts. So what I'm going to do is create these bins, or what we might see called classes. I'll pretty much always call them bins, except for right now, because those two are interchangeable. I want you to kind of know that both of them can be used. And these bins will then count the number of incomes that fall within those bins. So this might be something like, I want to count the number of incomes that I see in my data set between 0 and $20,000, right? Any income that falls in that range, I count it, right? And then now I have my frequency for that first bin. Next bin might be, do they make more than 20,000 up to $40,000? Count the number of salaries that are in that range or in that bin. Keep on going until I've counted every single income, right? Now, going from 0 to 20, 20 to 40, you kind of imagine maybe I have to make larger bins. Maybe the bin width can't just be 20,000 because I've got to go all the way up to like whatever Jeff Bezos is making, right? And so that's still going to be a really, really wide graph. But that gets the idea, right? And maybe if I had like a data set where I had more reasonable salaries in it, you can imagine going by $20,000 for your bin length would be fine. Sorry, so once we have all these frequencies, now it's just like it was before. We get relative frequencies the same way, we get percent frequencies the same way. It's just when we count those frequencies, we're gonna have to create these bins or these classes because there's just too many possible responses when we're dealing with a continuous variable, okay? So once we have these frequencies, if we put those into a bar graph or kind of these column charts that we just did, we're gonna call these histograms. It's really just a fancy word for that. We're creating a column chart or a frequency distribution graph where the data started out as continuous and we had to force it into these bins to make it more presentable, okay? But it's really no different than the column charts we were just doing, okay? It just kind of indicates to whoever's looking at it that, you've kind of summarized the data, you've taken a continuous variable and kind of forced it into these different bin ranges. Okay? So typically, the number of classes or number of bins we want to choose is 5 to 20. Right? If we only have like 2 or 3 bins, that's not going to be very interesting. Right? It doesn't really show us the kind of distribution because we've kind of lumped this. You know, if I did the income one, if I had 2 bins and said how many people make between 0 and $100,000 or $100,000 or more, well, it's not a very interesting graph. I mean, so, but once I get more than 20, now it's just, I've got too many bins going on. It's a real long graph. It doesn't visually look nice. So we try to keep it between 5 and 20. Right? There's no real set rule, but one way we can get an idea about what our bin length should be is once we choose the number of bins we want. So let's say I say I want 10 bins. Right? I'll look at my data. I'll take the maximum value of my data set and subtract the minimum value of my data set, and then divide it by that 10, that number of bins I want. That will tell me what the kind of optimal bin length should be, or at least gives me a starting point for about what my bin length should be. And we'll see how this isn't an exact science. But anytime you have a homework question or something, you might be asked to calculate the bin length. But when it comes to actually creating a chart, I'll make sure you're given kind of what that bin length should be. And we'll see why it might be a little bit hard to choose than just using this formula. Yeah, bin length, bin width, sorry. You can kind of use those two terms interchangeable. When you're visually looking at it, I think it makes a little more sense to call it width. When you're saying kind of the numbers, length probably makes a little bit more sense, right? Kind of we're going from 0 to 20,000. When we're thinking about kind of the visual of it, it's probably why I'm actually saying width as well. It really means the same thing. It's a good question. Just some general guidelines we want to keep in mind. If I can get this to, there we go. The bins should be mutually exclusive. So I kind of already said this earlier, and I didn't specifically highlight it, but it's easy to make this mistake. So when I said we want to count the number of incomes that go from 0 to 20,000, what I'm saying is there any income that's 0 up to or equal to 20,000? Then the next bin, I can't say between 20 and 40. I have to say anything greater than 20,000, right? Because let's say the first 2 bins were 0 to 20,000 and 20 to 40,000. What could be a problem with that? What if somebody made $20,000? They're going to get counted in both bins, unless I make sure I say not 20 to 40,000, but greater than 20,000, right? So we have to be careful with that equality. It can only be kind of on one side of those bin ranges or bin lengths, okay? And once we work with some data in Excel, I think this will become a little bit more clear. They have to be exhaustive. Just means that when we have the bins created, any possible response we could see for that income variable should be recorded in one of the bins. So I'll give you an example of how this might not occur. If we had the income example, and let's say I did something crazy like how many people make between 0 and 500,000, above 500,000 up to $1 million, between $1 million and 1.5 million, above 1.5 to 2 million, right? Those are my bins. Well, the problem is I'm going to have some uber millionaires that don't get counted because they make way more than $2 million, right? If I just stop on that last bin. So a lot of the times what we'll do, like with the income one, would be something like, let's go make our bins 0 to 20,000, 20 to 40, 40 to 60, anything above 60, right? That last bin, you kind of make this catch-all category where it doesn't have an end. It's just anything above this one number, okay? And we'll see, I can do an example of that. I'll kind of alter the Excel example that we're going to do a little bit to show you what would be the case if we needed that. I think the example I give you, we don't, but I'll show you what it would look like if we did. And generally, we want to try to keep these bins the same length. That's also, I mean, I feel like maybe I've already kind of inherently just been implying that. It doesn't have to be the case, but more often than 95+% of the time, we're going to do that. Okay? All right, so kind of going to this bin length, right? Just in case I saw some people writing, if you want to get that down. So, if we think about this bin length equation, where we should be starting out, an example might be something like this. And this might look like a question very similar to what you could see on today's online quiz. Okay? So SAT scores I've got for all these Indiana high schools. I want to do 9 bins, right? And kind of see how many, schools have an average SAT score that's low versus higher. So my minimum value is 352. My maximum school had a average SAT score of 648, right? I don't know where that was. That's insane. What should the bin length be, right? Well, we've got our minimum. We've got our maximum. We have the number of bins we want. It's really just a matter of plugging those into our formula, right? So we take that maximum, subtract the minimum, divide by that number of bins we wanted, which was 9. If we do that, right, we get about 32.8. So that's kind of the optimal starting bin length. Now the problem is I can use 32.8, 888 repeated, and it'll work fine. It'll capture every observation. Everything will be equal length. But what's a problem if I do that? If I try to put this on a graph, 32.88 doesn't look real pretty. And then once I start going up, I start getting all these crazy decimals that just look like a mess on the graph. So usually you'll use this formula to get kind of like a good ballpark about what it should be. And then you just push it up to the next integer. So when I say push it up, not round it, even if this was say 32.1, I would want to use 33, right? Because if I round down, what's going to end up happening is I miss that maximum observation. Okay? And I can kind of show you once we look at some Excel data of why that's the case. But anytime we use this formula and it's not an integer value, we want to just push it up to the next nearest integer. So that's why I say we'll kind of use 33 here. Okay? Now we don't have to. If we have something where it makes sense to use decimals, like maybe we're dealing with something with low dollar amounts, maybe it makes sense to go jumps of $1 and, I don't know, 38 cents, right? It's not as wild of an idea. But for here, just to kind of make the graph a little nicer, we're going to round this up to 33, okay? So we can do quantitative tables in Excel, build histograms, just like we did for qualitative data, okay? So how are we going to do that? And I've got some slides here. I'll actually update them. This was an old file, so some of the cell references are going to be a little bit different than what we do today. So I'm going to wait until we get done today to update those, just so I know exactly where I put things, because sometimes I accidentally just decide to go over one cell for no reason when it's all blank. So those will be updated so you have those as a reference, but we're going to actually just work through this together. So you can go on the in-class data folder on Excel, and originally this looked a little bit different. So if you kind of had it open last class, I can't remember if it was this section or the other one. I pulled this open briefly just to kind of show you, but I re-uploaded the file, changed a few things, got some more updated data. So here, got a bunch of different worksheets down here. We're going to be working with the state level data, okay? I think if we go over here, yeah, so this is the newest COVID numbers as of what, Friday? No, as of Saturday, I guess. So I've got the total number of cases by state and the total number of deaths in each state, right? So I want to look at a distribution to see, okay, do we have a lot of states where we have really high deaths, or the majority of states kind of lower numbers, right? So I want to get an idea about the distribution of kind of COVID cases across states in the US. Now, arguably, this isn't perfect. If I had time, or I mean, I probably did have time, but I didn't have interest in going out, grabbing populations, doing per capita, that'd probably be a little bit more of a fair apples to apples comparison. But this is a somewhat interesting data set that we can use to get at how we use continuous data and put it into a histogram. So you'll notice as well, I think, was it last class or the first class? Or no, it must have been last class. I said, if you wanted to get in a theoretical argument, why would the total of cases maybe not be continuous? Well, you can't see half a person die. But the range of values we can see is so wide, we're going from like 0 into the millions here, that we can treat it continuous, and really the same principles will apply, okay? So let's find that maximum. So I told you guys to remind me, and I've been kind of going off here, so maybe you just wanted to be polite. But if I ever forget to maximize this, let me know so it's a little bit easier for you guys to see. Okay? So I need to determine what my optimal bin length should be, right? Well, I think for this, I already kind of have the labels typed out. Just didn't want to waste class time. But let's say I want 6 bins. So I'm going to put the number 6 over here for the number of bins I want, okay? To get the optimal bin length, I need my maximum and my minimum and the number of bins I want. Well, I already chose the number of bins. So the first thing I need to do is find my maximum, okay? So I said last class, anytime we want Excel to do something for us, we put this equal sign and say, you probably have a built-in function I can use here. So equal sign max kind of works like the sum function. So it tells Excel, you know, if I tell you a bunch of cells, instead of adding them up for me, find the highest one, find the maximum. So I put equals max, parentheses. I select my variable total number of cases. So I can drag down with my mouse there. What else could I have done there? Does anyone remember the shortcut from last class? So I click on that first cell. If I'm on a Mac, which I'm looking out, I literally only see Macs. I think that, oh, you don't have one. So would be Command T, or if you're, no, sorry, I'm thinking of the freezing cells. On a Mac, this is, okay, so not on a Mac, it's Control Shift and you hit the down arrow. So on a Mac, it's Command Shift and you hit the down arrow, okay? If I do that, it'll go all the way down to the very last observation for me. So on a Mac, it's Command Shift, hit the down arrow. If it's on like a regular computer, or HP or kind of just sort of general PC, Control Shift, hit the down arrow. I should never start out with a Mac because that's not how I remember it. So I need to start out with a PC, otherwise that'll happen. So we'll hit OK or hit Enter. We can do the minimum the same way. If max was the maximum, min is going to be how we find the minimum. So select on that total case variable, Control Shift or Command Shift on a Mac, hit the down arrow. We can hit Enter, and it'll send us right back up there, and it found the minimum for us. Okay? So the next thing we want to do is find what that optimal bin length or size or whatever, however we want to refer to it. I actually kind of use those interchangeable, like the bin length or the bin width. So how are we going to do that? We're going to take the maximum minus the minimum and divide by the number of bins. That was the equation. So we're basically just entering that formula we had for the bin length into Excel. And instead of typing these numbers into a calculator, we literally just have to click on them, okay? So equal sign says do some math, take my maximum, subtract my, I don't know why it does this sometimes on my laptop. So this is what, cell I2. If I can't click on it, I can at least see I know where it's at. And then divide by the number of bins. Why is this going to be wrong? Yeah, right. I need to make sure that I remember that when I'm doing math in Excel, it's just like I'm doing it by hand or on a calculator. I need to think about my order of operations. I want to find the difference between the maximum and minimum first and then divide by the number of bins, okay? So that should get me my kind of bin length. Notice it's got some decimals. It's not real kind of nice round number. So I decided I'm going to round this up a lot, but just to make it look a little bit cleaner, I'm going to use 525,000, right? I'm pushing that up, actually, yeah, I'm pushing that up quite a bit, right? 525,000 instead of 512, 355.33. Just it'll look a little bit cleaner once we get to the graph. Right? So hit OK. There's my, if we want to label this, here's my kind of bin length that I'm going to be using. Now I want ahead of time, just so we don't have to save some time here in class, and I created these labels, right? So I kind of put, the very first one will be 0 to 525,000. The next one will be over 525,000 to 1,050,000, so on and so forth. Now I'll show you why creating these labels is kind of helpful in a little bit. And I'll also show you what kind of a better version of these labels would have been if we wanted to take a little more of our class time to do it. So I kind of have the minimum and the maximum of each one of my bins. Right? You kind of think about the income example I was doing earlier. I said we would need to go from 0 to 20,000, and then the next bin would have to be greater than 20,000 up to and equal 40,000, and so on and so forth. So we can do that in Excel pretty easily if we just use kind of what those cutoffs are for each bin. So the very first one, the minimum will just be 0. Right? That's the lowest number of deaths I could see. In that first bin, I want to count the state if it has a total number of cases, I said deaths, sorry, total number of cases up to or equal to that 525,000. Okay? So I'm going to use that 525,000. I'm not going to put a comma there. All right, so I've got that entered in. I could then go through and do that for all of the kind of next categories. I could just type this in. But actually, there's a little bit of shortcut I can use with cell references to update this pretty quickly, okay? So kind of notice, wherever the last bin stops, that's going to be where the next bin picks up, right? So the minimum of this bin will be equal to maximum of the previous bin. Now, we'll have to be more concerned about the equality, but at least that's where we kind of pick up. Okay? So if I do that, when I copy this down for this next bin, its minimum will be not J7, but J8, right? The maximum of the previous bin, and so on and so forth when I copy this down. So that's a nice way to use cell references. Also, the maximum of my bin will always be wherever that bin starts, kind of plus whatever the bin length is, right? You know, from the minimum of to the bin of the maximum, that should be my bin length. I'm trying to keep my bin lengths the same. Well, I've got my bin length up here, so instead of typing it in, I'm going to click on it. But now when I copy this down, my cell reference will go from I8 to whatever ends up being an I9, which is good, because for the next bin, I need to start at the minimum, add 525,000, get to the maximum. But I want to keep that bin length the same, so we will put $ signs in front of it, right? Freeze that cell reference. Okay. Now when I copy this down, it should kind of update for all the following bins, and I don't have to type all these numbers in, possibly making mistakes, taking more time. Right? In fact, what I could have done is in this very first one, I could have actually taken the minimum of the bin and added that bin length to it as well. Right? So I actually could have saved myself a little bit of work there. Okay. So now when I copy these down, notice they're exactly what I have as the labels, right? It kind of updates everything, kind of making sure every bin length, I'm just adding 525,000 to the minimum every single time. Okay. Here we have a question. H10 does not match the ending number in H9. So H10, oh. So this is why typing it in is a problem, right? I did 757 instead of 575, didn't I? Yep. So, you know, ideally, I would have looked over those labels a little bit more. But that's why, like, just typing the numbers in, you can kind of make some easy mistakes. That's why using these cell references and like adding your bin length is a little bit more of a fail-safe way, because we're actually going to just use these for a visual. These are what we're going to actually be using to calculate the frequencies. Okay? So that's a good question there. So how do I find my frequency for each one of these bins? Okay? So we're going to work off something we used last class, which was the Countifs, but we're now going to actually have to go a little bit further, which is to use this Countifs function. So for this very first bin, if we were going to do this by hand, what would you do? You'd go through this total cases variable, and you'd count the state if it had anywhere between 0 and 525,000 cases. Okay? Excuse me. So we're really checking two things there. Is it greater than or equal to 0, or is it less than or equal to 525,000, right? Is it somewhere in that range? So what we'll do is, the first thing it says, select the range of data you're looking through. So we're going to look through this total cases variable. So, right, Control Shift or Command Shift on a Mac, hit the down arrow, it'll select it for us, and I'll move this so we can see it. Comma. Right. The next thing we want to tell it is our criteria. So here, the very first thing we want to know, is it greater than or equal to 0? Right. Now, I'm going to do a little bit of a trick here, and I'm not going to include the equality, because for the next bin, we don't want to know is it greater than or equal to 525,000. We just want to know, is it greater than 525,000? Well, there's no state here with 0, so I can kind of cheat and know that it doesn't matter if I include the equality, and then when I copy it down, it'll work nice. So I'll just say, is it greater than, and then I have to use that and sign afterwards, right? Anytime we use an equality or a greater than or less than, put it in quotation marks. Use the and sign, and then is it greater than the lowest number of the bin, right? So now each time when I copy this down, it'll look through the data and say, if the observation is greater than the minimum of the bin, then I want to count it. That's like kind of the first check. And then I want you to kind of go back through, and the ones that were greater than the minimum, make sure they're also less than or equal to the maximum of that bin. So the next thing we do, we put a comma, we say, okay, we're still going to go back through and look through that same range of data. So you could Control Shift down arrow, select it again. Or since I already know it's C2 through C53. That's kind of what that colon means. I'm actually just going to type this out just so I can, oops, I forgot I typed it in again, didn't I? Just so I don't have to like kind of scroll down here or anything. So I'm going to go back through the data. I counted it first if it was greater than the minimum of the bin. Now I want to count it if it's less than or equal to, use an and sign, the maximum of the bin. Now, the way that you put in this greater than or less than or equal to or greater than or equal to, it's just how you say it. If I say greater than or equal to, notice, sorry, if I say less than or equal to, notice the less than sign comes before the equals, right? Less than or equal to. If this was greater than or equal to, I'd have a greater than sign and then an equal sign. Okay? Any questions on this before we keep moving? So this will go through the data. And 37, and I think there's Puerto Rico in here and maybe DC, so we don't have quite 50 states here. But of the states or you know, kind of areas of the US, 37 of them have cases somewhere between 0 and 525,000. Okay. Now, I set this up. I don't want to have to keep typing this equation out for the next 5 bins, right? But hopefully if I set up the very first one correct, everything else is easy. Because now for the next one, when I copy this down, I don't want to know is it greater than 0 or less than or equal to 525,000. So I7 and J7. I want it to be greater than 525,000, less than or equal to 1,050,000. So I7 and J7 will update when I copy this down to my new cutoffs for the next bin. But what will also update is the range of data, right? And I don't want that to change, right? If I don't want this to kind of keep moving down one, so I'm missing some of the first few observations. So I'll highlight this, I'll hold control. Oh, actually, I don't know if that'll work here. I thought I could select within the formula. I guess not. So I'll highlight this first. On a Mac, Command T, F4 on a computer, or if you have an FN key, FN F4, we'll put those dollar signs in there for you there. Go over here, same thing. Command T or F4 or FN F4, depending on your computer. And then the Command T is for Macs. So I freeze those cells. Let's see, I want us to be able to see everything that's in here. I'll go back one. There we go. Now when I copy this down, it'll keep using the range of data, but just updating to the new bin minimums and maximums. Okay? Any questions on that before we keep moving? Okay with that? All right, so we hit enter. Now when I copy this down, it counts the number in each one of these next bins. Now, this is kind of a weird variable, right? You can kind of see there's only like one state in this bin, one state in this bin, so on and so forth. The majority of states are under 1 million, essentially, right? Now you can probably kind of guess which states these are just based off of population. I think if we look through this, California is at 3, Texas is somewhere down here. There we go, Texas and Florida. You know, we kind of look through the data a little more carefully, but here's the data summarized, right? So you might say like there's a couple states where that's where the majority of these high number cases are coming from, okay? If we wanted to at this point, I could select my labels. Now because they're not right next to each other, I can hold control and select my frequencies, right? Because I don't want to select all the data, all this, right? I just want my labels, hold control, and I don't know if this is true on a Mac. You might have to hold command instead. Usually when I say control, it just is command on a Mac. Highlight my frequencies, go to insert. I can do one of these column charts and notice here's my labels. I could clean these up a bit so that they're like, drop the zeros and put K there or kind of do this in millions. You could play around with the formatting and the visual appeal of it on your own time if you really wanted to. I'm teaching you how to use Excel to just get the statistics to the graph. Okay. Any questions on that? Okay, so I'll show you, your first assignment will look a little bit different, but since we're at this point, I'll show you some cleaner labels. So some cleaner labels would be something like this, where you kind of include, is it greater than or equal to, like where is the equality? We could have done that in ours to be a little bit more, the visual would have actually shown where that equality was. And that's just typing in and kind of inserting some symbols, these less than or equal to symbols. It didn't take as much time to kind of clean the labels up as I might on like a homework. But you can see they're useful when it comes to graphing, because I can't, you know, what, am I going to just put the maximum of each bin on the graph? That doesn't really make a whole lot of sense. So that's generally why I kind of have this labels category, just to make the graph look a little bit cleaner. Any questions up to this point? All right, so what do we, 8 minutes, so we'll use the most of our time. So if I wanted to find the total number of observations here, if I add my frequencies up, if I've done this correctly, every single one of these observations should have been counted only one time, right? Should have been in one of these bins. So if I add up, use that sum function, and I add up all my frequencies, right? I get 52. Okay? I think that's correct. But a way I could check that, you know, I can count. You know, the very first row is not a observation, but everyone after that is. So I could look at the kind of row reference and probably figure out if that's right. But let's say I had a data set where like the data doesn't start down 35 rows, or you know, something where I maybe just want to double check. If we use this other function called count, all count does is whatever range of observations you select, it counts it if there's anything in that cell, basically if it's not missing. So count, put a parentheses, select my total case variable, excuse me, hit enter, counts the number of observations. It matches up with when we added up the frequency, so that's good. We've counted every observation in at least one of those bins. Okay? So that's, and you don't have to do that, that's just a check. So especially on these first homeworks, you'll have something that's kind of similar to this. Just because I did something in class here, it might have just been a way to kind of show you how to check or show you 2 or 3 ways of doing the same thing. You know, you don't have to do all of this necessarily in that first assignment. So this one is kind of a good example of that, where I'm just checking to make sure I did it correctly. So if I want to get my relative frequencies, what do I do here? How do I get a relative frequency from a frequency? I simply divide by
2.
I think someone might have said it on Zoom. Yeah, the total, right? The total number of observations. So if I've got the frequency for this category, 37, divide that by, I've got the total number of observations down here, right? That'll give me the relative frequency. Now this is perfect because when I copy this down, for the next bin, K7 will become K8, so it'll use the new frequency for the new bin. The only issue is K13 will keep updating as well. Well, I want to keep using that cell reference that has that total number of observations in it, so I can freeze it, freeze that cell reference, stop it from updating when I copy it down by using those dollar signs. Okay? Now when I copy this down, it'll keep dividing by the total number of observations, but use the next bin's frequency, and then the next bin's frequency, and so on and so forth. Okay? So now when I copy this down, I've got my relative frequencies. You can imagine the exact same way. I could highlight these, insert my graph, get my relative frequency kind of histogram there. I could take it one step further, do my percent frequencies. What's the only thing I would need to do here? Take my relative frequency and do what to get the percent frequency?
Multiply by 100.
Yeah, multiply by 100, right? Okay. Hit enter. Now I've got my percent frequency. If I copy this down, it'll keep using the next bin's relative frequency, so save me a lot of work. Now I've got my percent frequencies for every single bin. You can imagine this idea of like using cell references so I can then copy things down saves a hell of a lot of time, especially if I have like 20 bins, right? I don't want to have to keep typing all this stuff out 20 different times for every single one of these things that I want to calculate, okay? Any questions over any of that? Like 1 or 2 other things I want to mention before we get out of here, but I want to make sure
I do have a question.
Yeah.
How'd you get bin length?
Oh yeah, so how did I get my bin length, right? So that was where we used that formula to get an idea about where the bin length should be. And from there, I just made a, I guess I'll call it researcher choice, to choose a number that looks a little bit more appealing as a cutoff, right? In a homework or something, I'll tell you what that bin length should be, right? Unless I'm specifically, the question is just what would the kind of optimal bin length be, right? This probably is the optimal bin length, but not optimal for visual depiction, okay? Does that answer your question?
Yeah.
Cool, all right. So one nice thing about the way I had this set up, and the only thing it's not gonna update or it's gonna be an issue are the labels I created. There's probably some ways we could get around that, but maybe a little more advanced for this class. So other than the labels, one nice thing about setting it up this way, and here I could just take this bin length. Let's say I just did round up. So instead of kind of choosing, I think I want 1 digit. I forget how this works now. Let me see. Yeah, that's what I want. So don't worry about this function. I won't make you kind of use this. But instead of rounding all the way up to 525,000, maybe I just go to the next integer, right? Well, the nice thing is if I'm using these cell references, notice it updated the minimum, the maximum, and all the frequencies as well. So let's say I wanted to do more bins, right? Now I'd have to add more rows here if I wanted 10 bins, but I could just, right? If I have done everything correctly, I would kind of have to move these down, but just copy everything down. So instead of 6, I had 10 bins. But notice it's updating all the numbers for me, right? So it's going to save me a little bit of time if I go back and like want to change things. Okay? So that's really why cell references are so beneficial. Or even if we have the same number of bins, but let's say I'm going to change this back to 525,000 for a second. Let's say, well, actually no, I'm not. Let's say I don't know, I download the data 6 months from now, the numbers have changed, right? And the new maximum is something like 5 million, and the new minimum is, I don't know, 25,000. Well, notice it's updated everything for me, right? So this kind of makes it nice to where if I didn't want to go back in and the data has been more updated, it just automatically will update all the data for me. And if I had a graph created here, it updates that graph as well, okay? So these cell references are really, really powerful. Any other kind of last minute questions on that? Otherwise, we'll do a little bit more kind of just graph stuff. It'll literally probably take me a minute or two to show you next class. Then we're going to start diving into calculating some, where is that? Here we go. Calculating things like the mean and the mode. So we'll finish up kind of these graphs and tables and a little bit of Excel work on Wednesday, and then we'll jump into what we'll call measures of central tendency. Okay, so that's kind of the Learn Smart, the next Learn Smart I'll post after class today. When I say after class, I have one more class before I get a break, so it'll actually be like an hour from now. I'll get today's online quiz up there, as well as the next Learn Smart. Get on, get those easy points, just read that by the end of the week. Any other questions, feel free to email me. Check Canvas for that possible room change. Either today or tomorrow, I should hopefully be getting an announcement out about that, okay?
Hey, when are the online quizzes due?
So they're always due before the next class starts. So the one I post today will be due before class starts on Wednesday.
Thank you.
Okay? Hopefully you got that. If not, feel free to email me. All right, we'll see you guys on Wednesday. You guys, I'll see you Monday, or if I get a revised list, maybe sooner.